Hi guys, good morning. In this video, we are going to see the problem reducing dishes. I'm sorry, I am late, but I was just moving back to my hometown. It's the reason you can see the background change. So yeah, I was just traveling in the morning and then I have to do the work, and then just now I got a bit free to actually make it done because we made sure the video should come daily. And yeah, we are agreeing on that part and being consistent. You should be right. So yeah, let's see the problem pretty quickly. It says that a chef has collected data on the satisfaction level of his end dishes. So basically a chef has some end dishes and he has satisfaction level of these end dishes. Chef can cook any dish in 1 unit of time. So one dish can be cooked in 1 unit of time. Cool. Like time coefficient, just a variable name. You don't have to worry about it. What it means is that of a dish is defined as the time it took to cook that dish, including the previous all dishes multiplied by its satisfaction level, which means here it is the time. So basically the like time coefficient of our dish is nothing but the satisfaction I of that dish into what is this time. It's the time which is the sum of the time including to cook that dish, which is actually 1, because you know it's 1 unit of time, plus all the previous dishes which were cooked, which were, let's say if x were cooked, so it will be x plus 1. So ultimately we have to return the maximum sum of this particular like time coefficient, which is nothing but satisfaction into a time. And as we showed, what is this time? Let's say it is 3 into satisfaction of k. So basically the sum will be, I just choose some elements because it says that dishes can be prepared in any order, so I can choose, I have just, let's say, n dishes, so I can choose any dishes, and the chef can discard some dishes, which means I have to choose some dishes out of these n dishes and get the maximum value of what? Of this like time coefficient, maximum value of this sum, and this sum is nothing but by choosing some values out of this n values and computing the like time coefficient of those dishes, we get the particular sum, and we want to maximize that sum. Let's see how. So firstly, if we choose the first dish, any dish, let's say I have these n dishes. I'm just explaining the question right now. If I choose this dish, let's say it is the ith dish, so it's the first dish I choose, so its time would be nothing but 1, right? As I showed, the time is the present time, which means 1 unit of time to cook the dish plus the number of dishes which have been cooked so far. As the so far number of dishes cooked are 0, so its time is 1. So it is 1 into the satisfaction of that ith dish. What if I, let's say, want to cook the jth dish? Chicken, main thing, I'm just choosing a random any, because I just want to choose any of those dishes, any number I want, I can choose. So when I choose this second dish, so firstly one unit to actually cook that dish plus one dish has already been cooked before, which is the first dish, right? So in total its time will be nothing but 2. That's the reason you get a 2 into satisfaction of that jth dish. Cool. Let's say if I choose some k, then same satisfaction of the kth dish into, it's this 3. What is this 3? 1 unit of time to cook that dish plus how many dishes have been cooked so far? 2 dishes, which means first and second. In total it is 3, which I got here. Likewise, I can just get the sum, which is nothing but 1 into satisfaction of I plus 2 into satisfaction of j plus 3 into satisfaction of k, and so on and so forth, depending upon how many dishes I choose to cook. So basically I have to maximize this sum of like time coefficients. So I have to just maximize the sum of this like time coefficients. So you notice one thing, if you have a sum where you have a sum of values, something like 1 into, let's say values x, let's say it is x, let's say it is y, let's say it is z, and so on and so forth. So 1 into x plus 2 into y plus 3 into z plus, let's say, 4 into q, and something and so on and so on. If you want to maximize this sum, what would you think greedily? If we have some x numbers, x plus y plus z plus q, and you want to maximize it, so you always want that, okay, everyone should maximum. In here, everyone is nothing but a 4 into q or a 3 into z. So I want it to be maximum. Let's say 4 into q is not there. It is only there. A 3 into z is the maximum in the end. I want to maximize it because ultimately if I get a maximum number here, multiplying with a maximum number, I'm saying, okay, my 1, 2, 3, it goes up till 3 because as I go forward, it will go on increasing 4, 5, 6, 7. Let's say it goes into 3 only. So I just want to get maximum sum. I'll try to multiply the maximum value to that 3. So ultimately, if the maximum value of z, which is the satisfaction, is, let's say, some value, let's say 8, it's a maximum value in that particular array. So I get a maximum value from here. So ultimately, the logic, intuition which we thought, okay, we want the maximum sum of adding some numbers, I want it to be maximum. So every number should be maximum as much as possible. If I land onto some number which is this particular 3 into some value and I know it is maximum, I want to make it as maximum, so I try to make it also as maximum, because maximum into maximum will result in a very big number, right? It's the reason I want it as maximum as possible, so I try to multiply my maximum number with my maximum final unit of time. That is the whole intuition of this problem, that okay, I just try to choose the maximum satisfaction to multiply with my largest number. But you got observation that okay, I just grab the maximum satisfaction value if I knew I wanted to choose k elements. But what if I don't know what k elements to choose? Which means that okay, now I am confused what all elements to choose. So how about we start from scratch? How about we start from, if we want something as maximum, and we don't know right now, okay, how many elements we need, because ultimately it just says you need to choose some, because you can discard any number of dishes, so you need to choose some. And I also know I just want maximum, so I always start with the maximum value of dish, which means the maximum value of satisfaction. So ultimately I'll just start with one element, then I'll grab 2 elements, then I'll grab 3 elements, then 4, then 5. Like this, I'll just go on to every element. With this, I can get to know, okay, how many number of dishes I should take. Let's see how. So basically, as I said, to grab the maximum sum, I for sure need the maximum value of satisfaction. So in this whole particular array, maximum value of satisfaction is 5. I grabbed it firstly. Now, what is my final result? Result is nothing but the sum of light time coefficients. Light time coefficient is nothing but the time, and I defined how we get that time, which is like nothing but 1 into number of we have cooked the dishes into 1 plus number of dishes cooked into satisfaction of that particular dish. So if I choose a 5, result will be like nothing but 1, which is 1 dish have been cooked, and no dish have been cooked so far, it is 0, and 1 for this particular dish into 5 satisfaction of this dish, I got a 5. Now I'll try. Okay, I placed one dish. How about I tried placing two dishes? I placed five. Five will for sure come, and it will always come for the maximum value. I try to place another dish. Another dish I try to place, I will try to place a lesser maximum value than 5. Lesser maximum value than 5 is nothing but 0 in this particular array. So I choose a 0. 5 is here, 0 is here. As I said, I'll try to multiply, and you for sure know how will my array look like. 1 into satisfaction plus 2 into satisfaction plus 3 into something like this. Here the elements are 2, so it will look something like this. 1 into satisfaction plus 2 into satisfaction. As I want this to be maximum, I will try to place maximum value here, and then less maximum here, and then less here. So same, I just try to place my 5 with 2 and my 0 with 1, because it is 1 into something, 2 into something, and so on. So something is as maximum as possible. I get a 10 as a sum now. Oof, my sum is increasing, no? Let's try more. Okay, then I will have a lesser maximum value, which is -1. Let's see what will happen. I grab the -1. Again, same thing will happen. 1 into satisfaction plus 2 into satisfaction plus 3 into satisfaction. Same. 1 into satisfaction, 2 into satisfaction, 3 into satisfaction. As I said, maximum with maximum value. 5 is maximum, should go with maximum value, which is 3. Less than maximum is 0. It should go with 2. Less than maximum is -1. Should go with 1. That is the reason I just get the maximum value. Cool. I get a 14. Oh, damn. It's increasing, no? Let's try one more. Let's try next. Next comes is -8. I just have it. I just have -8, -1, 0, 5. Again, 1 into satisfaction, 2 into satisfaction, 3 into satisfaction, 4 into satisfaction. Again, 5, 0, it is -1 and -8. As simple as possible. I get an answer as 10. Oh, you saw one thing, what happened? It decreased. It decreased. What if I take another lesser value? Will it increase or decrease? If I would grab -9, it would increase or decrease? For sure decrease, right? Because ultimately you are just adding something more negative. It was already reducing. Now you are again reducing it by adding another number. So you find a point, okay, it was increasing. At a point it started decreasing, which was this point. So I just need to grab this. My 14 is my final answer, which is the final result. It is as simple as that. It was marked as hard, but it was not that hard. So ultimately, now you have an option. You will just grab the first and foremost, you just know for sure that you need to grab the maximum satisfaction value of a dish at any point of time. So firstly, you have to sort the array. You have to do it because you just need to grab that maximum satisfaction of that dish. So because you were grabbing 5, then grabbing a 0, then grabbing a -1, then -8, and then -9. So you just know, okay, I just need to sort it to get that in order. But after that, you just need to compute it. You just need to go on computing the final variable name was something very bad. Light time coefficient, yeah. Light time coefficient of every of this dish and get the sum. So you will get the sum here, you'll get the sum here, you'll get the sum here, you'll get the sum here. So for every particular, let's say you try one value, maximum value, again you try for maximum value which are 2, again you try for maximum value which are 3. You just go on trying for every value and see, okay, if it is going or not. So as simple as that. If you are just starting with 5, then 0, 5, then -1, 0, 5, then -8, 1, 0, 5, then brute forces that, okay, start with 5, then just go on like one loop, n elements, and every element can go up till maximum of n backwards, ultimately of n square. But although the constraints of this problem are pretty less, you can solve this problem in O of n square too. But can we optimize it? You got the brute force, right? just you have n conditions. Because of these n conditions, every condition I can just go at max n back. I can just go n back and just find the sum and just compute, okay, what's the maximum sum like, and ultimately I can just break down, okay, I'm just moving and finding the sum, moving and finding the sum. As soon as my sum goes decreasing, I can just break down. That's my answer. But it's O of n square. Can we optimize it? Let's see. Can we see some pattern here? If not, let me show you the pattern. So it is just recognizing a pattern out of it so as to optimize it. It's just numbers game, right? The pattern looks something like this. You had your result, which was 1 into 5, when you only had one element. Now you had this one element. Now you added another element, which was the next smaller element. 5 was the maximum element. Next smaller element, then 5 was 0. You added that. Is there any chance you can get this sum, updated sum as 10 in O of 1? Rather than just going on computing everything again and again, is there any chance you can get that in O of 1 or O of log n or something? Yes. Because if you see, you had this 1 into 5. The new condition which you had to make right now, it is 1 into 0 plus 2 into 5. So it can be broken down into 1 into 0 plus this 2 into 5. It can be broken down into 1 into 5 plus 1 into 5. This 1 into 5, it can come from above, and it is nothing but 1 into 0 plus 5, which is nothing but this prefix sum. As simple as that. Nothing but this prefix sum. Okay, cool. Let's see more. What can happen? If you had this minus 105, this minus 105, it ultimately need to have the result something like this: minus 1 into 1, 2 into 0 plus 3 into 5. It can also be broken down into minus 1 into 1, 1 into 0, 1 into 5 plus again just remaining 1 into 0 and the remaining 2 into 5. If you look carefully, this whole part was actually computed already above. As I grab this whole part of 1 into 5, I can just grab this whole part from above, and the remaining part is nothing but 1 into minus 1 plus 0 plus 5, which is nothing but the prefix sum again. So ultimately we can easily see that, okay, we can optimize in O of n, and ultimately my new result will be nothing but my old result, which is the above result. As I showed you above, the old result, I just marked it. The variable will remain same. Variable will remain a result. But I'm just saying, in the next iteration, that result will actually be a new result. So this new result will be updated by the old result, which is the old result, which is the previous result, and the prefix sum, which is nothing but the sum of all the values of this particular. As we are moving on, we can just keep on incrementing the prefix sum, which means here the prefix sum is 5, here it is 0 plus 5, which means just adding a 0, here it is 0 plus 5 plus minus 1, which means just adding a minus 1 in this, and so on and so forth. So my new result will be like nothing but old result plus prefix sum, and it is a final condition. I just keep on tracking this new result because it is increasing and decreasing. As soon as it decreases, I have got my final answer, which means my result will be my answer. As soon as it will go on decreasing. And as you're just adding prefix sum, I'll show. It is nothing but result plus prefix sum. Old result I have shown, okay. It is in the next iteration, our result variable will be updated by the previous result, which is this old result, will be updated by the new result, will become by old result plus this prefix sum. So how this result will get decreased? If in future, if it get decreased, it will get decreased if this prefix sum which we are adding, if this becomes negative. So it will just keep on reducing it. Ultimately affecting result was nothing but this prefix sum. So if it becomes negative, I can just say, okay, ultimately in future I'm just going to decrease and decrease, because ultimately I'm just adding a prefix sum. Until unless it's positive, I'm good to go. As soon as it becomes negative, for sure my result is for sure gonna decrease. Thus, I can just easily say, okay, my result is on decrease and I have to go. So complexity will be O of n log n plus n. N is nothing but to actually go on. N log n is for sorting, n is to actually go on to every loop. Just moving on one loop. And space is nothing but O of 1 because we are not using any extra space. Code is pretty simple. Nothing but that, okay, firstly we sorted in the descending order because we want a maximum in the beginning, because we are just grabbing that maximum value first. We are trying with that maximum value itself. Then I have the variables prefix sum, which will calculate the sum value of that particular whole part from starting. Then result, which is the final result, which will actually firstly increase, then at a point it will start decreasing. As it start decreasing, I know that my prefix sum will be less than 0 to actually make my result as decreasing, so I'll just break out. But yeah, last variable was n. Again, I'll just move on to the loop where I will just compute the prefix sum. It's nothing but addition of the satisfaction value. I just keep on adding the satisfaction value, which means 5, 0, -1, and so on. If at any point of time my prefix sum goes less than 0, ultimately I know that, okay, my prefix sum needs to be added in my result. So new result will mean like nothing but old result. It's nothing but same. When I say old and new, it is old means from the previous loop plus that prefix sum. So as the prefix sum is only being added, which can only affect my result, and I want my result to be maximum. So if this goes on to negative, then for sure my result will go on decreasing. It will never increase in future. So I can just break out and I can just return the result. Else I can just increase my result with this prefix sum and I'm good to go. It is very easy. So I hope that you guys liked it. If yes, then do hit the like button. I am being sleepy right now. I don't know why. But yeah, see you in the next video. Goodbye. Take care.